Alright, so these first three warm-up problems. The area of a regular polygon or pentagon, 5 sides. If the apothem from the center to like the median of one of the sides, right, not the vertex, not the corners, has a length of 4. And each side has a length of 5.8. Okay? So that means if I were to create like a triangle here and I have an area here cross section, the triangle is 1/2 times base times height, which is 1/2 times 5.8 times the height of 4. We just have to make sure we multiply this by 1, 2, 3, 4, 5. And you should get B. Okay? So that's an apothem. Some of you might have broken this up into those small right triangles. You just have to multiply by 10 instead of 5 to get the total. However you did it, 58 feet squared is the answer. Okay? So let's move on to number 2. Number 2, we're used to seeing graph positions. We're going to talk about this today as x, y. In three-dimensional space, you can graph x, y, z. Okay? So this is x, y, and z. And it's saying the value of z here and the value of y here, the answer is C. They are two equal numbers. Last but not least, number 3 has a lot to do with what we're looking at today. And I'm talking about subtle things that are important that we will test you on the test at the end of this unit to make sure that you understand every small little bit of detail. And you're not just, I think it's this. Okay? So f of x is equal to this function. And what this function is asking is evaluate when x is 2. So that means in the machine we're going to plug in 2 so that we get 4 minus 1/6. We multiply by a form of 1 so that we get 24 over 6 common denominator, so that 23 over 6 is my answer. Now, in Algebra 1, if I told you to plot the point 2, 3, 1, 2, 1, 2, 3, you would do that. Okay? Believe it or not, this notation right here is also a point. It just doesn't look like this. Y is the same as f of x. So what you are learning starting today is that when you see a value that looks like this, you tell me, what kind of value is that? For points, always for points. What kind of value is that? Y. That's a y value. So this is like saying the y value is f of 2, and what would the x value be? 2. So what you used to be able to see like this, for this particular one, the point, if I wrote it out, it would look like this. Okay? And now what you're learning is that this f of 2 is a y value just like you said, and it's equal to whatever that output is whenever I plug in 2 where x is at. So this and this mean the same thing. There were 2 words, again for points. So far we have that as far as those who just answered. For points, what were the 2 words that I mentioned last time in regards to x and y? Not varies directly. Nice try though.
What was that little example with the word combined?
Not that one, but nice try. X, write it down if you forgot. X is where or when, and y is what. What is the value? What is the value? So the way you're interpreting it is when x is 2, the y value is 23rd or 23 over 6. Where and what, okay? All right, new stuff. Guys, today's a big day, okay? Today is a big day as far as a lot's going to come at you. But it's not too bad. Please ask questions if you have any doubt whatsoever and you're not completely understanding of what's going on. because it's easy to get a little bit lost. Now, if you click on this link on your Google Classroom, on the calendar, I'm going to change this up a little bit. I'm going to use the equations that they have for sure, but instead of trying to slowly and slowly and slowly introduce you to what we're learning, we're going to go immediately to the full shebang.
Do you want us to do paper notes?
Yes, paper notes for sure. All right, this question says, what is the factored form? Factored form is something that we need to make sure that we understand today. Okay? Listing the zeros of the function is another thing that we need to understand today. Let's see who was listening last class. What are the three words mean the same thing as zeros? Roots, solutions, and x-intercepts. And x-intercepts. So roots, nice. Solutions, and x-intercepts. You have to make sure that you understand terminology, because as we talk through these questions, you're going to have to understand what is the terminology that they're asking me to do. Okay? So let's go ahead and go to factor this. Zeros of a function. Yep. Okay, here we go. What is that? What did I box? What is that? It's not a standard form. Nice attempt. And these are the subtle things that I'm talking about. Polynomial? No, not quite. Not the general. And it's okay. I love these. You're still getting points.
The one with 3.
The cubic?
The cubic.
Okay, so let me put it all together for you. Okay, here we go. Does it have an equal sign?
Yes.
Do you see an equal sign? No. So it's not a function. It's not an equation. It's an expression. Okay. So here we go. If I ask you to factor an expression, and you set it equal to 0, and you solve the zeros after that, you didn't answer the question. You see what I'm saying? Sometimes you can do too much. And these are those subtleties that I'm trying to get ingrained in your head of what is it that I'm being asked to do, okay? So here we go. I'm gonna build everything from this one little expression. What should I do to factor? Just say it out loud. GCF, perfect, GCF. Always try to GCF, pull out the greatest common factor, which in this case is x. And then I have my leftover scraps. Okay? Is it fully factored? No. Tell me why.
Because you can still, I separate it out into x minus 4 and x plus 3.
He's right, for sure. Am I now fully factored? Okay, and I want everyone to see why, okay? What do you notice about this that you could tell a third grader that you're done? How do you know I can't go any lower? There are no more powers that are bigger than what? 1. All of these x's are like to the power of 1. And once you get all the way to 1, you stop. Okay? That's how you know you're fully factored and you're fully reduced in that sense. Right? It's an understood 1. Maybe. Okay. So, and technically the 1 is here and the 1 is here. These are big, small. They're small details but big of importance. Okay? Okay, so right now I'm done with the question. This would be the answer. This is the factored form. Now I'm going to add to the question, okay? I'm changing it. We have the factored form, but if I asked you to list the zeros of the function, what am I going to do with this expression? This factored expression. Equal to 0. Guys, these are small things that I want you to be like, oh, as I show you now, rather than going to do the homework. Do you see why we call the x-intercepts zeros? Because the y value is what? 0. Here we go. What's this first x value? 0. What's the second x value? 4. Good. People who would make a mistake would say negative 4. What's the last 0? Negative 3. And the reason of it is that these values are what make each piece 0. If I plugged in this first one right here, it makes everything 0. Everything will become 0. Why? Because 0 times anything is 0. Okay? These are important. Let me ask you something. Bonus points, big time. How many terms do I have right here? 3. How many terms do I have here? Ooh, fast and speed. Nice. 7 period. 1 term. Because they're all glued together by what? Multiplication. Okay? If you don't know that, please write those subtle details down. I have to remember who I'm going to work point student here in just a bit. Alright, so these are my list of x-intercepts. If you don't have x equals, I will count off. Okay, so please make sure you write x equals. If you choose to write them like this, you will still get credit, but I'm a little leery of you doing that. The reason why is that the answers are not the whole point, right? They're just the x values. And I want to make sure you know that. Okay? These zeros are because they're the x-intercepts. Okay? What is going on upstairs? Alright.
What is this called? What are the
So what we're doing today is we are, let me show you. The turning points, the increasing, decreasing, what we're looking at is how to graph these functions basically without a calculator. We're looking at their in behavior as you go to infinity and negative infinity. Our goal is to be able to, if I go back to it, our goal is to take equations like this and be able to graph them by hand without even touching the calculator. Okay, there's a lot going on there. Finding out their answers. Their answers are where do they cross the x-axis. Okay? Questions? Okay. So right now my x-intercepts are taken care of. And again, you could write them either way, but I would prefer this way because it tells me that you truly know what the x-intercepts really are. But I don't want you to dismiss. You got to know this too. Okay? So now let's go ahead and graph it. The first one that I'm going to graph from left to right is when x is equal to what? 0. What's the next one? Negative 3. And guys, exactly the way I'm doing this, the way I'm putting slashes, tick marks, the way I'm writing the negative 3, all of this we're going to do for group bonus points here in a bit. And I want you to do it exactly the same way, okay? The origin, I don't have to put 0. What's the last one? 4. Now here we go. If I were to redistribute all of this, basically FOIL it all out, I could grab these two right here of x minus 4, x plus 3, this is just for practice, and I would get x squared plus 3x, And then I would do these two, minus 4x minus 12, because I'm multiplying, and I would combine like terms to get something that looks like this. I still have this x out in front. Then I would distribute, and I would go all the way back to my original thing. Now, from this thing here, how many terms did y'all say I have? 3. What's the most important term that really only matters? The leading term, the leading coefficient, the very first term, the one that has the biggest power of x. So you could see something like this on a quiz or the test. And if you did, from these x-intercepts that we've already plotted, we would be able to draw it. Okay? As I go to the right, it's going to do what? Go up. It's going to increase. How do y'all know that? Because it's a positive coefficient. Positive leading coefficient. First step. Okay? Second step. Because of this number, as I go to the left, it's going to do what? It's going to decrease. It's going to go down. It's always the opposite, right? Even or the same, like up and up, or down and down. And odd are like diagonal from each other. Either way. Okay? Here we go. So I'm going to go on a voyage. I'm going to start right here, and I'm going to head toward -3. And I have 3 choices. I can go through it, I can bounce, or I can squiggle through it. What do? I'm not going to squiggle. I'm going to go straight through it. And then I'm going to turn around and start heading back to the x-axis. And I'm going to head to 0. Okay, so I'm heading back toward the x-axis. And am I going to go through 0? Am I going to bounce off 0? Or am I going to squiggle through? I'm going to go through. Now I'm going to head back toward the x-axis. A good thing to know is that you're not going to have, they're called cusps, corners, okay? Like the absolute value corners. You're not going to have that. They're going to round and slow, smooth curve, turn back around and head toward the x-axis. All right. Do I go through, bounce, or squiggle? Go through. Now look, check this out. Ooh, that was horrible. So look. It verified. Because last notes, if I have one number less than 3, it has a possible how many changes of direction? 2. And there they are. You with me? Now, can someone tell me what's the y value of when it crosses the y-axis? 0. I don't have to write that. Let's say it was 10. I would want you to do that. If it did that. You with me? Okay? And you'll see what it looks like whenever that happens here in just a bit. Are there any questions yet?
How do you know like how tall to make it?
Okay. So there's a good question. So how far you actually go up, you won't necessarily know how far this is until you get to calculus. Okay? But everything other than that, you can know at Algebra 2, which used to be at pre-cal, but now it's even earlier. Okay? Yes?
Can you explain again how you know if it's a straight or a bounce or
Yes. So all of these went through because all of their powers, their multiplicities were 1. If it was 2, 4, 6, 8, 20, 120, any even number, what would it do? It would balance. You with me? And if it was an odd number, what would it do? It would squiggle through.
so if it's an odd number that's greater than 1, it's
Yeah. And here's a squiggle. This is what a squiggle looks like. Let's say that I want to go through this point right here, and I want to squiggle. You can do it to where it goes like from a frown to a smile. That's a squiggle. Or you can go from a smile to a frown. Do you see it? It almost feels like it's going to round off and then go back. So frown to smile or smile to frown, that's the squiggle. Okay? Please don't do this. This is not a squiggle. You know what I mean? Even though it kind of sounds and looks like it, it's only those first two. Any questions? All right, so here's the other thing that I wanted to show. Well, actually, let me go ahead and go to the second one before I show you it. Because I want to finish this next example before we go to lunch. All right, so our next one, again, I'm not really following the notes. I know what you need to know, okay? I'm not following the notes. I'm kind of combining everything together, okay? Showing you how it all fits together. What is the quartic polynomial? And, ooh, I might have went too far. I'm sorry. I think I went too far. Yep, I went too far. Here we go. What are the zeros of that equation? 0, 3, and negative 5. And you would lose points because I need to put x equals, okay? And again, this is x equals because these are the values of when it will cross the x-axis. So let me do that in that order. At 0, at 3 and negative 5, 2, 3, 4, negative 5, and at 3. Okay? All right. Does it say for you to FOIL this out, aka expand it out? No. So please don't think that you have to distribute, and then make it all where the parentheses disappear per se. We're not trying to make the parentheses disappear. We're just graphing it from this form. All right, here we go. Important question. How many terms do you see? One. One huge multiplicative monomial per se, right? With that being said, can someone tell me if you were to distribute it, what would that first term be? X cubed? Okay. Is there a number in front of the x? No. Okay, some of you saw it, some of you didn't. Check this out. X to the 1, x minus 3 to the 1, x plus 5 to the 1. So the biggest thing this could be is x to the 1. The biggest thing the second parentheses could be is x to the 1. And the last thing can be x to the 1. And we are multiplying all of this, and we add the powers. I'm going to change it up just a little bit. Yeah?
So if there was only two terms, like it would be x to the x squared.
It'd be
It's just
x. Well, it depends, because I'm about to change it up. And that question I felt was coming. That's why I'm going to change it up so that you can answer it here in just a bit.
Wait, I have a question too.
Yep.
On the first example, we did, like, whenever we put it together with the, whatever, put it together and that, we just did ones and we didn't make it, we didn't make it three.
Yeah, exactly. So we didn't have to make it 3. My point is this. Let's say that instead of what it says, it had 2x like this, negative 2x. It had 3x minus 3 squared. And the last one had like 4x plus 5, just like that. You with me? Check this out. You could distribute everything. That is a nightmare if you don't have to do it. This is what I'm talking about. Know what you're supposed to know. If I didn't say write the standard form, you don't have to distribute this. Do you see how much of a nightmare this is to distribute? You would have to do this. Oops, let me color coordinate it so you don't get confused. Come on, computer. You would have to do this. Okay? So you would get 9x squared minus what? 918x plus 9. Then you would distribute this on 4x plus 5. distribute, 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 add them all up, put parentheses, and finally you'd have to distribute negative 2x. That's a lot, and yes, you will do that this unit. One of them, next problem, okay? But I'm showing you, you don't have to do it because it never asks you to write the standard form. Now, look at this, okay? Well, not that. So look at this piece that I trying to help with what Aaron's question was. If I don't have to distribute that, what would my first term be? Here we go. Here we go. Careful. X squared. Yep. X to the what? First. Yep. And x to the what here? First. Raquel's right. You're going to have an x to the fourth. But now we have to think about the leading coefficient. Here we go. This one is what? Negative 2. What's this one's leading coefficient? 9. You see it? So it would be, what's the last one's leading coefficient? 4. So if I multiply all this out, what am I going to get? Negative 72. You don't have to do anything more. So you got to know what you're being asked and prioritize your time. Otherwise, you might be doing something that you weren't even supposed to do, and you will never finish that problem. Okay? So, do we understand? And from there, you just know how to graph it. Okay? So let's keep going from our original problem. I just wanted to make sure I kind of extended it so that you could see the case scenarios that you guys were asking about. But let's do the question that it was asking. Here we go. Y'all said the leading coefficient is x cubed. You're exactly right. As I go to the right, what? Increase. As I go to the left, decrease. Why? Because 3 is odd. Here we go. We're about to go on the journey. We're going to start from over here on the left. I'm going to head toward negative 5. Do I go through bounce or squiggle? I go through. Turn back. Do I go through bounce or squiggle? Go through. Turn back. Do I go through bounce or squiggle? Go through. How many changes of direction were possible? 2. There they are. You tell me. Does this guarantee that there will be 2 changes of direction? These are for bonus. Does it guarantee that there will be 2 changes of direction? No. Not completely. If x cubed is all by itself and there's no extra terms, how many changes of direction? It could be 1 or it could be 0. Because x cubed, remember we looked at this graph last time, looks like this. It had never changed directions. It never went from increasing to decreasing. You see where I'm going with this? But if you have more terms, yes, this comes into play. We good? Okay. So we listed the zeros. We graphed. We showed what the change of the direction would be. We haven't even touched the calculator. And this is really accurate, by the way. Okay? Any questions before I continue to go? Alright. So we're going to start the next one. I do not expect to finish it yet because it is a hefty one, but I want you to think about what we're about to do before you go to lunch because it's good momentum right now. Here we go. This is what you're going to not... This is the thing that's not fun. When you see this on the quiz or test, yeah, you're about to do some work. Okay? My goal is to write the equation in standard form and everything that comes to the right of that. What did they give me? Okay, let me rephrase this. They gave me 4 factors. True or false? False. They did not give me 4 factors. They gave me 4 zeros, roots, x-intercepts, or solutions. I need to build those factors from those answers. Let's build the first one. What is it? X plus 2. What's the second one? X plus 2. What's the next one? X minus 2. And x minus 3. How many of you, be honest, raise your hand, would have actually wrote what we just said like this? Good. That's the way you should write it. Because this is going to tell you when it what? When it bounces, right? Here we go. Our first one is where? Where is this at? No. Okay, see, that's what I'm talking about. I have to go back and forth to make sure you see what we're doing. This x plus 2 is right here. As a factor, as a 0. We plot the zeros. Okay? What's the next one? 2. What's the next one? 3. Now here we go. As I go to, okay, tell me.
Do we only have to plot it once?
There's the question. Yes, you only have to plot it once. This will tell you, come on, computer. This will tell you whether it's going to go through, bounce, or squiggle through. It'll bounce. Okay, so first of all, here we go, here we go, here we go, here we go. Can someone tell me what is my first term ultimately going to be? X to the 4th. What's the number in front? 1. And then everything else, right? So as I go to the right, I'm going to increase. Why? Positive 1. As I go to the left, I'm going to what? Increase, because it's an even number. You with me? And how many possible changes of directions do I possibly have? 3. Here we go. Let's go on the journey. We're going to come from up here. Do I go through, bounce, or squiggle? Bounce. Turn back around. Do I go through, bounce, or squiggle? Through it. Turn back around. Do I go through, bounce, or squiggle? Through it. You see it? And I know what you're about to ask. What is that y value going to be? Well, that's a y-intercept. Answer this question, then we'll go eat lunch, okay? This is a y-intercept. That means, what is 0? Guys, what is the y-intercept going to be? What has to be 0 to give you the y-intercept? X has to be 0. Just like on an x-intercept, y has to be 0. On a y-intercept, x has to be 0. So if I put 0 here, 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 and here, I would have 2 for this piece, 2 for this piece, negative 2 for this piece, and negative 3 for this piece. Multiply all that together, what would I get? 24 is where it would go and cut through that. And again, it could happen before or after the hump, if you will, the max. I'm not worried about you knowing that. And we'll pause there and come back. Go eat. Alright, so to continue. How many terms? One. And what we did is we identified the zeros as negative 2, 2, and 3. Someone asked me this the other period too. Do you have to write negative 2 times because it's bouncing? You don't. Because it's a double root, you can just leave it as 1 time. Okay, and if you do write it twice, I'm not going to count off, but you don't need it. Let's see. Again, yes, you can if you want. I would prefer you not to, but you could write the x-intercepts like these as well. And then, just to reiterate, this 24 comes from plugging in 0 for all of these x values, because that's x is equal to 0 will hit the y-axis. Okay? So it yields these values of, this would become 2, this would 2, -2, -3. When I multiply all that, I get a positive 24.
So it's the same as
Well, think about it this way. Don't think about it like zeros or x-intercepts or solutions. Just think to yourself, if I plug in a 0 here, 0 plus 2, back when math was way easier, is just 2. If I plug in a 0 here, 0 plus 2 is still 2. That's where I'm getting these from.
So
And then
where
you
did
just,
you get the 24 out of that?
because 2 times 2 is 4, times -2 is a -8, and then -8 times, because you're multiplying all these, a -3. Negative times a negative is a positive, so you get a positive 24.
So is it better to draw after you figure out what your y-intercept is, or can you just kind of squish it where it looks like?
You could squish it wherever, yeah. Now here comes the fun part. Okay, here we go. We're about to do this in standard form. You have to learn how to get organized, and you have to learn how to work fast. So look, I'm about to distribute these 4 separate factors. Okay? Now let me show you, because everyone's different. And if you have 4 separate factors, what you do first, there's 4 to choose from for the first one. After you've chosen one, there's 3 to choose from left. After you've chosen that second one, you have 2 left, and then the last one, you'd have 1 left. Guys, there is 24. If I multiply all that, there are 24 different ways that you could do the next step. Sometimes people will do things the same. Sometimes they'll do them differently. It's okay if you do work differently than someone else. But the goal is you need to develop what you feel is comfortable for you so that you end up at the same answer at the very, very end. Okay? All right. This is what I would do. I would see this double root, or this multiplicity of 2, means the same thing. And I would probably, from a rule that we learned way back when, this is a squared plus 2ab plus b squared. And if you don't remember that, that's okay. You don't have to. You could break this up into 2x plus 2's, and then just FOIL. Some of your skills are different, okay? If I FOIL this, I would get, go with me, okay? We're gonna distribute and FOIL the red. X plus 2 squared. What would I get?
X squared plus 4x plus 4.
Perfect. Do you think I need parentheses? Oh yes, definitely need parentheses right now. Okay? So now, the leftover in blue, what would that FOIL to?
X squared minus 5x plus 6.
That's awesome speed, guys. Seriously. Plus 6, right? And guys, if you can't see it like that and you need to do one at a time and do these, that's okay. There's nothing wrong with that, because we're about to do that right now. How many of you have ever FOILed out 2 trinomials together? Yeah, I didn't think so. Okay, here we go. We're going to first start by distributing x squared to everything. Here, here, and here. So I'm about to blank x squared to all of those things. What goes in the blank? Distribute, which is multiply. Okay, make sure that you remember when you're multiplying and adding. Alright, so together, come on. Let's go ahead and distribute this first x squared term, and you tell me all together, what do I write? X to the 4th, 5x cubed, plus 6x squared. Perfect. Let me ask you something. Do I still need parentheses? Not anymore. Because these are the last 2 terms that are falling out that I won't need any more parentheses. You with me? There's a lot to remember again, but it's not bad once you get to practice. Okay? So, now let's distribute the second term. And I'm color coordinating them, okay? So what's the next one? 4x squared. Oh, my bad. 4x cubed. Keep going. Minus 20x squared plus 24x. If you don't know what's going on, you gotta flag me down. Now it's the 4. We're distributing, aka multiplying. What do I write? 4x squared. Perfect. Now, I know on your paper, some of you use colors, and that's cool if you do, because it's easier for you to see. I use colors too. I'm just that kind of person. But if you're just using a pencil, this is what I would suggest to you. How many x to the fourths do y'all see? 1. Oops. That's a 4. How many x cubes do y'all see? 2. Cubes, and this is just me. You can choose whatever shape you want. I use triangles. Because on the squareds, I use squares. Okay? How many cubes will I have? Like, put all your x cubes together? Or negative 1, right? Negative 1x cubed, because it's a negative 5 with a positive 4. How many x squareds? Negative 10. And then the last one, how many x's? 4. And then plus 24. Guys, if you didn't realize this by now, in standard form, it's even easier to see what the y-intercept is going to be. Because the y-intercept, again, like you said earlier, will happen when all of these x's are 0. There it is. You see that? Okay. Questions? Okay, so with the calculator, you're going to follow me real quick. Okay, be handy on the calculator for sure, because I want to show you how you're going to be able to check your work in group bonus points if you're fast. And the reason why I want to reward you for learning the calculator is because there's still a lot of cool things that it can give you where you're still learning and not just replacing the knowledge by just aka cheating, because that's not how I'm showing this to you. Okay, so I'm going to begin this class. I'm going to sign in just real quick. And next class, guys, you will have logins. Will you be able to sign in as well? You see how my screen pops up here? You'll be able to sign in where all your screens will pop up. And if I clicked on Erin's, she could, from her seat, show us up here what she's doing from there. I could click on anyone's and make you the presenter. Now look, this equation that we just finished doing, the factors are, follow me, press 1 for a new document, no to unsaved changes. Press 1 for a calculator page. We're going to press Control Doc to add a page and press 2. We've done this since day 1. And in f of 1, I want you to type out, bonus points are coming up, x plus 2 squared times x minus 2 times x minus 3. So here's what I'll say. Important stuff. Are these multiplication symbols required, do you think? Okay, here's what I'll say. They are. Sometimes you can get away with it. If you forget to put them there, they will put them there for you. But who can tell me why they're very important, that you should always put them in there? Because otherwise, it could give you an error. Who can tell me why? for 200 points.
After the square.
No? Good guess, though.
Come on, guys.
It'll add it up instead of equals what I think.
No, that's a good guess. He's saying that they could possibly add them up. My point is, if I put in the calculator just parentheses, it doesn't know all the time to multiply there. It's so advanced, ironically, that it doesn't know that you mean to multiply. And it will give you an error sometimes. What have we done this year that you can say, oh, it's because of this? What have we done? No worries. Remember when we used to do this? Compositions. Do you read this as F times G times X? No. So parentheses doesn't automatically mean multiplication. You have to tell it to multiply, otherwise it might be thinking that you're trying to do a composition. So let's press enter together. There's the graph. Okay, now look. If I want to alter this graph, so far I see this bottom piece way down here, as far as the max goes, whoops, and it looks pretty good, or the minimum. I don't need to move that. But up here, I can't see this maximum over here. Like it's not there. So I'm going to alter the window, and you're going to have to do this too, so that it'll show. Okay, here we go. Menu, zoom, or sorry, menu window, my bad, I'm sorry, no zoom. Menu, window, and I'm going to do settings. And I want to make the top Y values, the positive Y values, the max ones, go higher. So let's say 50. Go big or go home. There we go. So now the entire graph is showing. And that graph, you can see, looks very close to our graph. You with me? Only our graph, we had the maximum on the left side, and over here you can see on the calculator that the maximum is on the right side. But you don't know that. I'm not going to count off for that. That's calculus. Okay? But everything else, it bounced where it was supposed to. It went through where it was supposed to. Everything else is good. Okay? Any questions? When we do group bonus points here in just a bit, the last minute of each drill, I will let you use the calculator however you want. So let's say you didn't know how to do anything, and at the very end, you just put it all in there in 1 minute, and you were able to draw it and put it all out, you could still get full credit, because I want you to get good at both. This is supposed to be used to check your work, not replace your work. Let me show you something else cool. Look up here. Press Control left. Press Control right to go back. You see how you can jump back and forth between pages? And I want you to press Tab and go up to F of 1. What we're about to do is we're going to be lazy and use technology to our advantage and put the cursor right there and press Shift down. And then Control C, the letter C, like on your keyboard, because we just copied all that. Press Control left to go back to the home screen. Follow me. Press Menu, 3 for Algebra, 3 for Expand / aka Foil, and we're going to press Control V, and it does all that for us. Everything that we did by hand, and it grouped it all together to make sure that what we had as an answer was in fact correct. Yes?
How did you get it to copy?
Okay, so to copy again, press, let me go to the right. Go to the very front of this. If I want to copy everything to the right of my cursor right now, press Shift, it's the key above 7, and then press down.
Like just the down arrow?
Yeah, just the down arrow.
And then,
And then press Control C. Control C is copy.
I just did saving.
Control V is paste. So you could come over here, Control V, Control V, Control V, Control V all day.
So you're pressing,
Yeah, don't do that. That was just me being annoying. But menu 3-3, Control V, done. The only thing that you would have to put in front of this is a y equals, or f of x equals. What's the degree of this polynomial? 4. The degree is 4, right? How many possible maximum changes of direction could it have? 3. We good? All right, here we go. Your first example, and guys, the first one I'm going to give you 5 minutes to work.
We're done with paper notes.
We're done with paper notes. You can put these questions that I'm about to give you for group bonus points still in your notes if you want to. I would highly recommend that you do.
How many are there?
There's 3. Here we go. The first one is make sure you're not doing too much work. Make sure you only do what I ask you to do. I want you to list the zeros or the x-intercepts, and then I want you to graph in great detail the y-intercept, the x's, the arrows, the squiggles, the throughs, and the bounces have to be accurate. Any questions?
So it doesn't have to be insane.
It does not have to be in standard form. Okay? Here we go. Alright, so I'm restarting the time. I'm re-recording right now, real quick. So list the zeros. 1, -3, and -2. I gave team 5 points because a student made an error, and instead of -3, wrote -27. What error did that student make that other people have made before? And I want to make sure no one makes it anymore because we can learn from that.
Instead of -3.
He cubed it. You don't have to cube the zeros. Leave them as what those numbers were. He took -3 and he tried to cube it to get -27. Okay? Listen, team 2 had a question as far as how do you get the y-intercept? And I heard one of their teammates say, look at the last number of each one and multiply it all through. That hurts just thinking about it, okay? And I say, if it's y-intercept, x equals 0. X-intercept, y equals 0. So if I want a y-intercept, and I put 0 here, here, and here, this is what I was trying to show you earlier, this becomes -1 squared. This becomes 3 cubed. There's the O moments. This becomes 2.
And that's when you find the y-intercept.
This is how we find the y-intercept, because we could just multiply all this together. What's -1 squared? 1. What's 3 cubed? 27. What's 2 times 27? 54. So on the graph, what Raquel was saying earlier, we could label it first. We could go and say, here's 1, here's -3, here's -2, and we're about to go.
That stressed me out.
Our biggest power, if you were to FOIL all this out, would be x squared, x cubed, and x to the first. Are there any numbers in front of those x's? No. Are there any numbers in front right here, like an a value? No.
But what if there were?
If there were, then we would account for it.
We just multiply it to all of them, or one
Just to the very first one, because only the first one matters. So this would give me x to the, anyone? 6th. The rest, we don't need it. Because of the fact that this is a positive 1 in front of the biggest power of x, that means we're going to go up like this. Because this is an even number, that means we're going to go up as we go to the left. Because there's so many more things that you will have, chances are it's going to be 5 changes of direction. Okay? Here we go. Let's go on the journey. Heading toward -3, what do I do when I get there? At -3, I squiggle through -3. You see what I did? So that was a little dirty, but I'm going to squiggle through -3. Okay? And then I'm going to head back to the x-axis. Do I go through -2? Do I bounce? What do I do? I go through it. Now I'm going to head back toward,
You bounce.
and then I'll bounce. Look at that. Each green highlight, keep track, each green highlight is 25 points. Okay? Then, watch. The squiggle through bounce, y-intercept, and these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each one is 25. Alright, so one more time. Just this piece. We knew it came from the top because we always look to see first what is it going to do as you go to the right. Because this was a +1, it's going to go up. Step 2. Is this even or odd? It's even. So as you go to the left, it's also going to mirror and go up.
So if that was odd, it'd go up on the right side, but down.
But down over here if it was odd. Okay? You have one more example, maybe even two. Your next one, listen, I want you to find everything, including the standard form. Y is equal to x cubed, oops, times x minus 5. I know, this is going to hurt. Well, there's